Hello everyone. Alright, so now let's look at the next example, and now we are going to deal with conductor and also the free space regions. So if you get to the equations, example 5.10, page 210. So now for this case, we are given an E field that actually propagate within the free space region up here. Let's say we assume the first region here is your conductor, and then the second region here filled by the free space, and at this region we have E field, so this one E field, E number 2, given as 60 X component plus 20 Y component minus 30 Z component. So now we are going to find the D and also the rho S at certain point at P here, right? So assuming that there's a P here, this is on the interface between these two regions. So we want to find what is the D at here and also the rho S at this particular point. So now again, back to the normal and tangential components. So from normal component we have these equations. So D2n minus D1n is equal to rho S. Right guys, so we know that during our last lecture when we talk about the conductor under static conditions, so whenever the E field passing through a structure of conductor, so by right there's no E field within the conductor. Alright, so automatically we know that E1 here will become 0. Okay, so and also we know that the D1 here also will become a 0. So we can simply simplify this equation that here part will not have any value 0. So finally we know that the D2n is equal to the rho S. That's the first charge. Okay, so now using the second tangential component equations, we know that the E1 tangential is equal to the E2 tangential, right? So we know that E1 is equal to 0, so by right there's no E1 normal, there's no E1 tangential. As given here, the E1 is equal to E1 normal plus E1 tangential. So since there's no E1 vector, so automatically we don't have any E1 normal and also we don't have any E1 tangential, so all becomes 0, and automatically we don't have E2t as well, because this equation will lead to 0, isn't it? So from E2 equation again, so E2 vector also can be decomposed into two main components, the E2 normal plus the E2 tangential. Since we know that the E2t is 0, so we know that this one have 0, so automatically the E2 normal is equal to the whole term of E2 field as shown here. So here we can simply note that this is equal to the E2 normal component, right? So E2 component. So from here we can simply find the rho S equal to D2n. So to finding the rho S, just taking the D2n, or if you want to put vector also can, just put vector and just take the magnitude. So now from this equation you can know that 60 epsilon naught milli square plus 20 epsilon naught milli square plus minus 30 epsilon naught milli square, and just take square root of all of it. So now we can find the value of rho s, and now we're going to have the value of 0.619 picocoulomb per meter squared. So again guys, if you find the D field here is actually the value of this E2 and times with the epsilon naught. So again, to find the D vector at this P point, or you can simply say that D2, just put the epsilon naught E2. So the D2 can be expressed as shown here, the epsilon naught 60 x component plus 20 y component plus 30 z component millicoulomb per meter squared. So that's how we find or we solve these problems. Okay guys, I hope you can try yourself and make sure you get the same answer, and if you have anything to ask, just let me know. So all the best. Thank you.